we'll start off today's workshop by welcoming our first speaker of the day, and that is Christian Pinto, the co-chair of the Open Fabrics Alliance Open Fabrics Management Framework Working Group and a staff research scientist at IBM Research Europe. He's here to present the work of the OFA Open Fabrics Management Framework Working Group in his session called Managing Composable Disaggregated Infrastructure with OFA Sunfish. Take it away, Christian.
Thanks, Phil, and good morning, good evening, everyone, depending where you are. So let me share my PowerPoint. Awesome. Okay, so we got too many windows. Perfect. So Phil already did my introduction, so I'll just delve into the topic. And so I'll start by mentioning, I'm not the only one involved with this presentation, so I'm presenting it, but there's been a lot of work from everyone in this list. So without all these great people, we wouldn't be at the stage where we are today with Sunfish. So let's just quickly recap. So basically, the goal here is to address the management of disaggregated composable systems, if you want, what we used to call like network systems or distributed systems, right? Now we have the ability to compose at the finer grain down to single memory and accelerator devices. And the problem that we have is that you can buy disaggregated technologies or network technologies from a number of vendors, and usually each vendor comes with their own API. So infrastructure managers today are asked to deal with different pieces of infrastructure, different management software, and it's becoming some sort of a cumbersome task for managers. And also the other issue is that since these systems are becoming extremely complex and the level of composition that you can reach is very fine-grained, you might want to start using smarter techniques such as AI or alike to compose and configure your system. Now, the fact that every hardware exposed their own interface means that different fabrics are going to require for different optimizations. So we have to do something, right? And this something is Sunfish, right? So this is the response that the Open Fabrics Alliance has to this problem. So many of you are probably, let's say, familiar with Sunfish. So this is what we promise, right? So this is the overall goal. So completely abstracting the hardware from the clients with this Sunfish framework. So the Sunfish framework is based on DMTF's Redfish and also SNIA's Swordfish specification. So that's the language that Sunfish, if you want, speaks with clients and with the hardware. And what it gives you is that it gives you a centralized framework to control multiple fabrics in your system, and everything is done via either a normal RESTful interface, what we would expect from a Redfish service, or via Redfish events. Now we have the notion of Sunfish agent. So the Sunfish agent is actually what translates Redfish into the actual dedicated specific API for the hardware. So you might have a CXL fabric manager, you might have an NVMe over fabrics hardware manager, an InfiniBand manager. All these managers have their own API. What the agents do is translate this API into Redfish. So in most of the cases, one would expect that these agents are provided by the hardware vendors. So far in the workgroup, we've been focusing on the core Sunfish services. So to actually, first of all, design and define on paper what these services are, what they offer to clients, and what are the requirements from the perspective of the hardware side, let's say, and how do they interact with each other. So we have I will introduce our software release later on, but we have a reference software that implements today a number of these services, mostly the inventory, the tree management, resource configuration, fabric configuration, and also the management of the agents. Then we've been focusing on building actual agents. For building actual agents, you have to attract hardware manufacturers who are willing to expose their API into Redfish, basically, so that they can be interfaced with Sunfish. Here, the work is being mostly done on two directions. And one direction is actually understanding what does the Sunfish requirements for mapping hardware systems into Redfish objects. So for instance, we've been doing a lot of work on CXL to figure out how Sunfish expects, for instance, fabric attached memory to be represented and things in that direction. And at the same time, we've been working with vendors for implementing actual Sunfish agents that can be interfaced with Sunfish. And the last part where we've been focusing so far is events, basically. So the interaction between agents and Sunfish and clients is mostly happening via asynchronous events. So the events are also part of the Redfish standard, and we use them basically for agents. For instance, when an agent wants to notify something to Sunfish, I don't know, the state of a device changed, I have a new device, one device is gone. All of this is done via events. And then Sunfish also plays the role of an event broker. So clients can actually subscribe to different events from different agents. And whenever these events occur, Sunfish will be notifying the clients that are subscribed for the specific event types. Even for this, we follow the rules of the Redfish event specification. So Redfish is let's say fundamental for the activities of Sunfish. Then we also started working on the composability layer part. The composability layer part is where you would have the intelligence for automatically controlling and optimizing such a composable system. So you would have policies, you would have a monitoring of the infrastructure, so that you can actually use the monitoring data for improving your policies and so on and so forth. So clients will be able at some point through the composition layer, to ask, let's say in an abstract way, to ask for resources that they need. Then the composability layer will actually translate this into Redfish messages for Sunfish, and then of course Sunfish will deal with the agents and actually make the changes happen. So okay, this looks all complicated. Why would anyone do this, right? So why do we need Sunfish at all? The idea is the following. So think this that you see here at the top of the slide is a computer system represented in a very super simplified Redfish tree. So you have some systems where systems are the compute nodes, and then you have resource pools that are interconnected to the systems via different fabrics. So if users need to configure their systems so that they can use a number of accelerators, a certain amount of memory and storage, the user will need to know actually the details of the fabrics, which let's say fabric manager if you didn't have Sunfish, which fabric manager to talk to, which specific messages to send to the fabric manager, and so on and so forth, in order for you to get the final system that you actually composed system that you actually need. So what Sunfish is doing is completely abstracting all this complexity from the clients. So the clients can simply focus on the on the composed systems. So basically the clients can ask, I need the system with this much memory, this and this many GPUs. And through Sunfish, this is actually done. And the result for the user is an enhanced system. The user doesn't need to know which fabric manager, hardware manager to talk to, which language to use, and so on and so forth. Sorry. So, for instance, one use case, this was provided by our colleagues at the FSAS Technologies. One use case would be, I want to leverage a composable pooled resources through Kubernetes. So what you would achieve with this type of infrastructure is that the user will just request, I need a GPU for my container. So for who is, let's say, up to date with the Kubernetes jargon, you would create a resource as a resource request, a resource claim, how they are called today. So there is a component in Kubernetes, it's called dynamic resource allocation, that actually is monitoring these resource claims and makes them happen. So basically, whenever you submit a pod or a container, if you want, to Kubernetes with this resource claim, this DRA controller will first see, okay, is this claim fulfilled already? Yes or no? If not, it will actually fulfill it. So what happens here is that this DRA component is interfaced with Sunfish, and basically will use Redfish to communicate Sunfish that it needs a GPU on this specific node so that the pod can be executed on it. So using Redfish sends this message to Sunfish. Sunfish is actually interacting with the actual hardware. So through the agents, the GPU is connected to the node and the container can be executed. All of this is completely hidden by the user, right? The user is just asking for a GPU for running their container. So one place where you would do this is that you have a system with a bunch of GPUs, but your GPUs are not always running at maximum load, so it's time dependent. So you always have a number of GPUs that are unused. So these GPUs, even if idle, are consuming power. That it's slow. In this example, with 10 GPUs, the power reduction that you get by switching the idle GPUs off is 6%. But if you see this at the scale of the data center, these become quite important numbers immediately. And also, using the composable disaggregated infrastructure, what you can do is that if a GPU is not needed on a node, you just remove it from that node, and instead of keeping it off, you can assign it to another workload so that you maximize basically the utilization, and basically you capitalize on the investment, because these GPUs are several thousands of euros per device. So basically, after all of this, Sunfish is finally out. So today we are announcing the first release of Sunfish, which is our version 0.3. So what we have released, we are releasing today in this presentation, is the official documentation of Sunfish and the reference software implementation. So the official documentation is available on our GitHub. Afterwards, you can either click the link or scan the QR code. It will bring you to where the documentation is. But basically, the documentation describes, gives a bit of background on Sunfish, but then describes all the components in Sunfish and the interactions between the components, also the interactions between Sunfish and the actual hardware agents. It describes the management of the life cycle of the agents, so registration, failover, everything, and which Redfish and Fortwith schema we adopt, and if there is a need for extending those schemas, the specific extensions that we came up with, as well as some modeling requirements redfish modeling requirements that Sunfish is expecting, for instance, for CXL fabric attached memory. Our reference software implementation is broken down in 3 pieces. So we have the reference Sunfish core library. This library is a Python library that implements the core services. So it's a tree management and interaction with the hardware agents, so registration of the agents and sending commands to the agents and so on and so forth. And then events brokerage, of course. And this is available on GitHub already. Of course, what most of what is in the code is described is in the documentation. We also have a reference Sunfish server implementation. So the Sunfish server is what gives you the RESTful API for the Sunfish core library. And the last piece is the reference Sunfish hardware agent. So it's the reference the agent reference code is still a work in progress. We will release it in probably a couple of weeks. Most importantly, we are working on CXL agents and also the API for managing CXL fabric attached memory, and we will be releasing a reference agent that can be used with mockups. So even if you don't have an actual hardware, you can bring up an agent, for instance, with the CXL fabric mockup, bring up a Sunfish server, and then actually experiment with the full Sunfish experience. On the agent, we also have some, let's say, example agents that are interface with the actual hardware. And for obvious reasons, these cannot be released open source because they actually use proprietary APIs that one would only be aware if they bought the actual hardware, right? So this we've been using for experimentation. I will show you a demonstration today, but this will not be released open source. So that's just a picture of our community in case someone is interested on who's joining the workshop and who's been contributing so far. I will not go through all the partners. And another important announcement today is that we actually have one real product that is natively coming out with a Sunfish agent. So this is CXL memory appliance from H3 platform. This appliance is for basically memory disaggregation over CXL. So here we have some details, right? This appliance uses the fabric manager from H3 and then a CXL switch from XCon, and then can house E3.S CXL memory modules. So basically this can be natively, and this is a product that is going on the market, right? This will be natively interfaced with compliant with Sunfish. So you can out of the box interface this device with the Sunfish framework. So what the agent does is that it represents the entire fabric, whatever the hardware is, in Redfish. So because also the agents are also expose a Redfish RESTful API, right? And so what the H3 agent does is that it exposes all the CXL switches available and all the memory devices available. And then these are associated with fabric endpoints, that these endpoints are actually a logical construct that allow clients to connect, for instance, a compute server with a specific memory device. And we'll see more in the demo. So this, for those who like the hardware diagrams, this is actually a few diagrams of the chassis. So this chassis have a network, regular, let's say, Ethernet network interface, that it's the one through which you can reach the Redfish endpoint. And then they have CXL ports for the hosts, and then you can plug the E3.S modules in it. So the E3.S modules are the actual memory devices that users will be able to attach to the host. So now I will demonstrate Sunfish with some real hardware. So I will show you a system in which we have, let's say, an infrastructure in which we have a number of computer systems, these systems on the left, and two different fabrics. The fabrics, that is a CXL fabric that is basically enabling a memory pool that can be dynamically attached to hosts, and also a PCIe fabric. This PCIe fabric is based on hardware from Liquid, which is a US company that builds composable hardware or based on PCIe. And in this case, we have a GPU pool. And basically, this would be the entire Redfish tree of the system. What we have is that on each fabric, we have some endpoints. So these endpoints represent systems and devices. So what we want to do is that we want to dynamically, for instance, in the CXL platform, connect the endpoint associated to system 2 with the endpoint associated to a device, a memory device. And at the same time, we want to do the same with the PCIe fabric. So we want to connect the endpoint associated to a system with the endpoint associated to a GPU. And in the demo, I will show you what does that means in Sunfish and how much knowledge of the actual fabric do you need to have for you to perform this connection. So the demo is actually depicted here. So we have Sunfish at the center, which is up and running. And then we have two Sunfish agents. One is the CXL agent that is provided by H3 and is interfaced with the H3 hardware. And then there is another agent, which is actually interacting with the PCIe fabric manager. This PCIe agent instead was built by us, by IBM, for the specific demonstration. So here it's important to say that, as you can see, you can even have the hardware built by one company and the agent built by someone else, or the company providing the entire stack from the hardware to the agent. And the important thing to understand is that Sunfish is open, but by using by adopting this agent system, what we do is that the hardware vendors can keep their secret sauce secret, basically, and bake it into the agent, because they are not required to release the agent open source. The only requirement that you have on the hardware vendor is that their manager exposes a Sunfish API. But the actual, let's say, business logic can be kept secret. So it's open, but it leaves a freedom to the manufacturers for implementing their special functions in a closed source fashion. So here I will show you how the agents register their fabric and what Sunfish does for actually crawling each Redfish tree and building the single Redfish tree for the entire system. And then we see a client, and in this case is a curl, requesting attaching either memory or GPUs to a specific system. So this is basically a web interface. If the video starts, this is a web interface that shows the Redfish tree exposed by Sunfish. So here we see that we have systems and these aggregation sources. These aggregation sources is the Redfish object that you use for representing an agent. So here Sunfish knows already that there is a CXL agent, and the fabric type is CXL. What's the endpoint and the UID, and the same Sunfish knows there is a PCIe agent, what's the UID, and what's the endpoint. But so far, these agents have advertise no resources. So the redfish tree of Sunfish is basically empty. You can see it there. So this is the dashboard of the H3 appliance. It shows 128 gigabytes CXL memory device. And this one instead is the server to which we dynamically attach devices, GPUs, and as you can see here, we don't still have any GPU attached. So what we are gonna do is we're gonna first start with the agents, right? So each agent is a redfish endpoint. So I'll show you here, this is for instance the PCIe agent responding to a curl and responding back with the entire redfish, let's say the root of the tree. And this is the CXL agent. So what we will do first is that let's have the CXL agent advertise its fabric to Sunfish. So what it does is that generates an event. This is the payload of the event, saying in the context, the agent will say, okay, I am agent specific UID. I have a new resource, which is this fabric. And what the agent does is it sends an event to the event listener endpoint of Sunfish. So now you will see that both the agents and the clients use Sunfish. One other thing that I want to mention here is that this would be done automatically by the agent. Normally, I'm doing it here manually in the demo because I want to show what is that the agent does for registering. So the agent sent the event to Sunfish, and Sunfish started the crawl process where it found, okay, this agent does a fabric. So now in Sunfish, you see a new fabric, which is a CXL fabric with a number of endpoints. So for instance, endpoint 1 is the actual memory device, and this S1T11 is the actual system. So what I'll show later on is how to actually connect the memory at this endpoint with the CPU at the other endpoint. What Sunfish does is that after it does the crawl up, it's also recording all the devices, all the resources that belong to a specific agent as part of the aggregation source object. So now we do the same with the PCIe agent. So the PCIe agent does a similar thing. It will just tell, okay, I am agent specific UID. I have a new fabric that is named like this. So Sunfish receives this agent and they start the same crawling procedure. As you can see, the endpoint that the agent uses is the same, right? Because Sunfish is let's say a unique entity in the infrastructure. So now this is done, and we can see that there is a new fabric in Sunfish that is a PCIe fabric. This fabric has an endpoint for every GPU and an endpoint for every node. So what we're gonna do is that we're gonna connect, we'll try to connect the GPU1 endpoint with the PCPU1 endpoint. So PCPU1 endpoint is a compute node, and the GPU1 endpoint is, of course, a GPU. And this fabric also advertises a system, because in this case, the system belongs to the fabric. So the fabric can also say also have a system, and this composable 04 system that I'm SSH2. And here I'm showing that by navigating the endpoint, you can also get to see that the device is actually an A100 40 gigs. And here again, for this agent, I'm showing the same thing, which is all the resources that belong to the PCIe agent got attached there. Should there be a new resource, the agent would send a new event, and Sunfish would update the tree and make sure that the event exists. So now we're gonna try to connect these two endpoints. So for doing this, now we are playing the role of the client. I want to connect my compute system with a specific memory device. What you do is you have to create a connection, which is an actual redfish object, between two fabric endpoints. For doing this, we send a specific message to Sunfish, which is the endpoint is, of course, the Sunfish endpoint, create a connection on the CXL fabric, and these are the details of the connection. The details of the connection is a JSON at the top of the screen, basically listing the two endpoints. So we send this message. Sunfish, in this case, it replied with the full connection being created, adding also the agent that now manages this connection. And what it did is that when it received this connection creation request, it actually forwarded it to the agent. The agent did the actual attachment of the memory to the CPU. And now, if we refresh the dashboard of the CXL memory appliance, we can see that the 128 gigabytes of memory got attached to a host. And there is also some information of, here we see a memory chunk got created. These are the specific characteristics of this memory chunk. Now, if we visit the fabric, of course, in Sunfish, now we also see that there is a connection between the two endpoints. So Sunfish is aware of the complete state of the system at all times. Now, what we want to do is I want to connect a GPU to a compute system. But one would think that by this being completely different technologies, the type of interactions that you need to do with the hardware are much different, which is true. But the beauty of Sunfish is that even in this case, what you do is just you create a connection between two endpoints in the fabric. Nothing more is required to the client. So we do something similar. That's the payload of the connection. But now, this time, we are asking Sunfish, create a connection. We do it with a post on the PCIe 10 fabric. And that's the details of the connection. So basically, exactly the same command, same type of payload. We are connecting devices with a completely different technology and a different vendor. So now we got the same response, so the full connection details. And if we go and inspect the node, we're going to see that now the node physically got an A100 40 gigs GPU attached. And of course, since everything went well, if we go and inspect the fabric, Sunfish will show us, okay, you have a connection, you have a new connection in this system between two specific endpoints. And basically this concludes the demo. So basically the goal of the demo was not only showing how the agent and Sunfish interaction works, but also that with Sunfish and Redfish, we are completely abstracting the details of the fabric and the vendor-specific language to be used, right? We use Redfish, and with the connection, we were able to attach system with the memory and the system with the GPU. So to conclude, so the Sunfish community is rapidly growing. So we've been attracting a number of users lately, and also hardware vendors. And this is one of our, let's say, a big focus for us is to creating an ecosystem of Sunfish agents. Now we want to move into integrating with clients. For instance, we want to have proper integrations with Kubernetes for the cloud side, or Flux for the more HPC side, and demonstrate that all of these clients, even though they are from completely different domains, they still use the same API. And this year, we're going to be at Supercomputing 24 in Atlanta. So come visit us. The details will be made available in due course. And also, please, everyone, join the community, right? We welcome contributions in many things. Integration with workload managers, integration with parallel computing libraries, implementation of more agents for real products. And anyone is free to join. We saw that our meetings are 7 a.m. Pacific time every Friday. There is a calendar invitation on the Open Fabrics website. Join the mailing list, or if you want to ask a question and if you don't want to join the mailing list, you can email myself or Michael, who is the other co-chair of the work group, and ask us any question. And this concludes the talk. So if there is any question, I'm happy to take it.
We're a little over time, but yeah, I'd love to get some questions in real quick.
Well, was okay.
I do have actually two questions. One of the questions is, does Sunfish compliance add any additional latency to the communication between the client and the hardware?
There will be definitely, let's say, some latency added because, let's say, Sunfish acts like a man in the middle, if you want, right? You interact with Sunfish and then Sunfish interacts with the agent. However, this type of interactions, even in reality, are not expected to be done at the millisecond level and with high frequency, right? We are not talking like frequently allocating memory in a system. These are more cross-grained actions that you do for reconfiguring your system. So the added latency is going to be there, but it will be minimal with respect to the scale of the overall interactions.
And that's admin path too, by the way.
Exactly.
Yeah, it's not fast path data.
Exactly.
The other question, I know I want to run to the next presentation. If all the enclosure managers in my installation already offer a Redfish API for managing resources within the enclosures, why do I need a Sunfish agent to plug the Redfish models into the Sunfish core Redfish database?
That's simple, because if you have a basic Redfish API, it's true. Your system can work with Redfish, but if your system is used alongside other hardware, right? If the admins are embracing Sunfish, they will be able to integrate all the hardware from all the vendors that use Sunfish under a one API, but then they will not be able to integrate your hardware within the same API solely because you don't register as a Sunfish agent.
Right.
So you get the benefit that you are plug and play basically in every Sunfish compliant system.
Right. The way I might summarize that is if you're in a heterogeneous environment and you want to be interoperable with other pieces of hardware. Yeah, exactly.